Welcome to Math Tutorials. In this video, we are solving every question of exercise 5.2 of Chapter 5, Continuity and Differentiability, from the NCERT Mathematics textbook for Class 12, Part 1. Exercise 5.2 has 10 questions, 8 chain rule differentiations of composite trigonometric functions, and 2 proofs that a corner and a jump destroy differentiability. Here they are. Question 1. Sine wrapped around the polynomial x squared plus 5, a two-layer composition for the chain rule. Differentiate the outer sine at the inner function, then multiply by the derivative of the inside. Name the layers. The outer function is sine, the inner function is x squared plus 5. Chain rule. Derivative of sine is cosine, evaluated at the inside, times the derivative of the inside, which is 2x. Write the factors in the usual order. Question 2. Cosine of sine of x. Trigonometric functions stacked 2 deep. Outer cosine, inner sine. The outer function is cosine, whose derivative is minus sine. The inner function is sine x. Chain rule, minus sine of the inside times cosine x from the inside. Question 3. Sine of a linear expression with constants a and b. The inner derivative is just the constant a. Outer sine, inner linear function a x plus b whose derivative is a. So the derivative is a cosine of a x plus b. Question 4. 3 layers this time, secant of tangent of root x. The chain rule applies twice, peeling one layer at a time from the outside in. The layers outside to inside, secant, tangent, square root. Derivative of secant is secant times tangent. Derivative of tangent is secant squared. Derivative of root x is 1 over 2 root x. Collect the 3 factors over the root. Question 5. A quotient of 2 chained trigonometric functions with 4 constants in play. Quotient rule on the outside, chain rule inside each piece. Set u as the numerator and v as the denominator. The chain rule gives their derivatives. Quotient rule, u prime v minus uv prime all over v squared. The double negative becomes a plus. Question 6. A product, cosine of x cubed times the square of sine of x to the 5th. Product rule first, then the chain rule on each factor. Product rule with the 2 factors named. First factor, minus sine of x cubed times 3x squared. Second factor, 2 layers, the square and the sine, then the power x to the 5. Assemble both pieces. Question 7. Twice the square root of cotangent of x squared, 3 layers under a constant, root, cotangent, and x squared peel off one by one. Chain rule through the 3 layers, half over the root, minus cosecant squared, and 2x. Cancel the 2's and collect. Optional tidy form. Write cosecant and cotangent in sines and cosines, and use sine of 2 theta equals 2 sine theta cosine theta. Question 8. Cosine of the square root of x. A gentle 2-layer chain rule to close the differentiation set. Outer cosine gives minus sine. Inner root gives 1 over 2 root x. Combined into a single fraction. Question 9. The modulus function shifted to have its corner at x equals 1. We must prove the corner really breaks differentiability. The 2 one-sided limits of the difference quotient at 1 must disagree. The difference quotient at 1, f of 1 plus h minus f of 1 over h, and f of 1 is 0. From the right, h positive. The quotient is h over h, which is 1. From the left, h negative. Modulus h is minus h, so the quotient is minus 1. The one-sided limits differ. 1 against minus 1, so the derivative at 1 does not exist. F is not differentiable there. Question 10. The greatest integer function on the interval 0 to 3 with its jumps at 1 and 2. Differentiability implies continuity, so a jump is enough to destroy the derivative. At 1, just below, the greatest integer is 0. At and just above, it is 1. The one-sided limits disagree. At 2, the jump repeats, 1 from the left, 2 from the right. Every differentiable function is continuous, contrapositive. A discontinuous function cannot be differentiable, so f fails at both points. That completes all 10 questions of exercise 5.2. In the next video, we will take up exercise 5.3 on derivatives of implicit functions and inverse trigonometric functions. Thank you for watching. If you found this video helpful, do like it, subscribe to math tutorials, and share it with your friends.